Okay, now last time we have discussed about the center of mass of the system of n particles. In this question we have discussed that there are a n number of particles m1, m2 up to mn are the masses and their position vectors are say x1, y1, z1, that is position vector for first is say r1, then for the second it is r2 and so on. Then you can write this position vector of the center of mass as, say, we can write it as in general r, position vector of the center of mass, which can be written as vector r is equal to, in general we can write m1 r1 plus up to plus mn rn, okay, upon m1 plus m2 plus up to plus mn. Okay, and this is nothing but the total mass of the system, which is denoted by capital M. So we can write the position vector of center of mass as r is equal to m1 r1 plus up to plus mn rn, okay, upon total mass of the system. Okay, this we have understood, and this can be explained in this way: x component, y component and z component. Okay, now this is written here in general, okay, so you can easily understand it. Okay, here it is position vector of center of mass is equal to sigma mi ri upon the total mass, or we can say m into position vector of center of mass is equal to, we can write m1 r1 plus up to plus mn rn. This is the expression for the center of mass, or we can say position vector of center of mass of the system of n particle, and this is given in our topic number 7.3 on page number 148. Okay, so now we shall proceed that motion of center of mass. Now see, when you want to find the motion, then first of all this equation which we are having, we are taking the time differentiation of this equation, or we take the differentiation with respect to sign. So position vector r will be written as dr by dt. Here also it will be dr1 by dt up to drn by dt. So we can write it like this. The equation is differentiated, so m into dr by dt is equal to m1 dr1 by dt plus m2 dr2 by dt plus up to plus last term mn drn by dt. Now as you know, dr by dt is velocity. So instead of dr by dt we write v, that of the velocity of center of mass. So we denote it by capital V, which is also shown in page number 148. So mv is equal to m1 v1 plus m2 v2 plus up to plus mn vn. So this is the expression when the system of n particle, or rather we can say center of mass, is moving. Okay, so whenever there is a change in position, this will be the expression when the particles are in motion. Okay, now this will be the expression for the system of particles when they are in motion, and this v shows the velocity of center of mass. Okay, now by using this, again if you differentiate this, then this differentiation will be of velocity, and velocity will have its differentiation and it will be resulted into acceleration, and then you can find the mass into acceleration. This velocity will also will be resulted into acceleration. So mass into acceleration will result in the resultant force acting on the system of particles. Now that is discussed in this further. Okay. Now this expression which we have derived can also be written as velocity of center of mass v is equal to m1 v1 plus up to plus mn vn last term upon total mass. That total mass I can put in the denominator, and that is total mass, which is the sum of all the individual masses, that is m1 plus m2 plus up to plus mn. Okay, so this can be written in this form also. Now see, now I will take the differentiation of this particular equation. Okay, so what will happen now? See, here this expression which I have tried to explain is written in the different form. Okay, again it is written in the original form, that is m into v, m1 v1 plus m2 v2 up to mn vn, when m is nothing but m1 plus m2 plus up to plus mn. Again you are differentiating with respect to time, so dv1 by dt, dv2 by dt, here it becomes dv by dt, and this dv by dt is nothing but acceleration of center of mass. Okay, so instead of this capital dv by dt, it is written as capital A, and then dv1 by dt, dv2 by dt are replaced by small a1 a2 up to an. So this equation can be ma is equal to m1 a1 plus up to plus mn an, and if you make the capital A, that is acceleration of center of mass, as a subject of formula, then this expression will be obtained. Okay, just we have taken capital M in the denominator of this. Okay, and capital M, as you know, it is the sum of all the masses. Okay, now as you know, ma is nothing but mass into acceleration, which is nothing but the force. Okay, so we can write this ma as force acting on first, that is f1, f2 up to fn. So mass into acceleration is nothing but the resultant force acting on the system of particles. Hence the vector sum of all the forces acting on all particles of the system is equal to the product of total mass of the system and the acceleration of its center of mass. Okay, now we consider that the force acting on n particle of the system. Now try to understand, we have derived this formula, that is ma is equal to f1 plus f2 plus up to plus fn. Okay, now see, we have taken two particles as a representative particle, 1 and 2, and external forces are f1 and f2. There are internal forces, force on 1 by 2 and force on 2 by 1. This is a mutual attractive force, but they are equal in magnitude, opposite in direction, so they cancel out each other's effect. Now these forces F1 and F2 are considered to be acting on the center of mass. So if its center of mass is somewhere here, okay, it is here, then this force is acting on center of mass, that is F1. Okay, and the other force F2 is acting on this center of mass. If you try to understand, if you are pushing the door, then you are as such applying the force to a particle, but the whole force is as such acting on the center of mass of the door. So two forces are acting. So now law of parallelogram is taken, complete the parallelogram, and this will be the resultant force acting on the center of mass. So whenever external forces are acting, then they are considered to be acting on the center of mass. Internal forces are taken to be equal in magnitude, opposite in direction, so they are cancelling out each other's effect. So whenever we talk about the acceleration, then it is only due to external force. Okay, only due to external force, and that a mass into acceleration will be equal to resultant external force. Okay, so that resultant external force is responsible for the motion of system of particle. Okay, now some important notable matters in this F external is equal to ma. To determine the motion of the center of mass, no knowledge of internal force of system or particle is required. Only you have to consider external forces. Internal forces are equal in magnitude and opposite in direction. They cancel out each other's effect. Okay. To obtain this equation, we did not need to specify the nature of the system or particle. Whatever type of nature of the system or particle, this equation is applicable. Okay. So no need to specify the nature of the system or particle. Okay, whatever is the system and the motion of its individual particles, the center of mass moves according to this formula, that is ma is equal to f external. This is the formula which is applicable to whichever system and the motion of individual particle may be. Okay, now we talk about the explosion of projectile. Now try to understand a bomb is moving on a trajectory, moving in a gravitational field, so it will be performing a kind of projectile motion. Okay, so it explodes in between somewhere. Okay, in a fragments, in say 2, 3, 4 fragments. Okay, the force leading to the explosion are internal force. Whenever the explosion is made, what do? You have ignited the wick. Okay, and there are internal chemical process which is responsible for the explosion. So they contribute nothing to the motion of the center of mass. Nothing to the motion of the center of mass. Center of mass will move as it was moving earlier. There is no contribution of these internal forces for the motion of the bomb. Okay, it was earlier moving. Whichever way it was moving, it will continue to move. Total external force, the force of gravity acting on the body, is the same before and after. So what will happen? Its center of mass will move in the same direction as it was moving earlier before the explosion. The center of mass under the influence of the external force continue. Okay, external force continues. Therefore, along the same parabolic trajectory, it will move after explosion also. So after explosion also, the center of mass of the system will move on the same trajectory. Whichever way the fragments are moving, say one fragment is moving this side, the other is moving this side, third is moving this side, whichever way, but the center of mass of these fragments will move on the same trajectory where it was moving earlier. Now if it is asked that obtain the expression for the velocity of center of mass, then it is very easy to find. First of all, write the coordinate of the center of mass. R is equal to m1 r1 plus m2 r2 plus f2 plus mn rn upon m1 plus m2 plus mn. Okay, this is total mass, so it is replaced by capital M, which is again multiplied here in the next step. So mr is equal to m1 r1 plus f2 plus mn rn. If you differentiate, then dr by dt you will get. Okay, and that dr by dt is velocity of center of mass. dr1 by dt, dr2 by dt are replaced by v1, v2 up to vn. So if you replace those quantities, then mv is equal to m1 v1 plus up to plus mn vn, and if you make v as a subject of formula, then m1 v1 plus up to plus mn vn upon total mass, that is m1 plus m2 plus up to plus mn, you can write. Okay, this way it can be asked. Now show that the total momentum of system of particle is equal to the product of total mass of the system and velocity of center of mass, which can be shown easily. This is the formula which we have derived, that is m into velocity of center of mass is equal to m1 v1 plus up to plus mn vn. Okay, and as you know, p is equal to mv and dp by dt is equal to force. Okay, so instead of this m into v, we have written capital P, that is momentum of the system of particle, or rather momentum of center of mass, and these are the individual momenta of different particles. Okay, which can be replaced as m1 v1 plus up to plus mn vn. Okay, now this p which we have written capital P, okay, capital P is nothing but mass into velocity, that of the center of mass. Okay, so we can say that the linear momentum of the system of particle is equal to the product of the total mass of the system and the velocity of center of mass. Okay, very easy to understand. Now we shall discuss the law of conservation of momentum for the system of particle. Now see, this dp by dt is equal to f external, because external forces are only playing the role. Okay, if the sum of external force of the particle is 0, then f is 0, then dp by dt is 0. Okay, so dp by dt is 0, it means dp, that is change in momentum, is 0, and when change in momentum is 0, it means that initial and final momenta are same. Okay, so p is constant. Now p is constant, it is equivalent to three scalar equations which we can write. Px is c1, py, that is the momentum in y direction is constant, or momentum in z direction, or p3, that is constant. Okay, where c1, c2, c3 are constant. When external total force acting on the system of particle is 0, then total linear momentum of the system remains constant, or we can say total linear momentum remains the constant. This is the law of conservation of momentum. If ma is equal to f, and f is the external force, if f is 0, then what will happen? Mass cannot be 0, so acceleration is equal to 0. Okay, acceleration is 0. What does it mean? When total external force of the system is 0, velocity of the center of mass remain constant, acceleration is 0, so velocity remains constant. Okay, and as you know, acceleration is dv by dt, and acceleration is 0, so dv by dt is 0, so v is constant. Okay, when velocity is constant, okay, we can say there will be no change of momentum. Okay, we can say the total external force of the system is 0, then velocity of center of mass will remain constant, and this is the law of conservation of momentum for the system of particles. Okay, now the new topic that we are going to discuss is the cross product or a vector product. Now try to understand. We have understood the dot product, in that it is a scalar product. When two vectors are multiplied and it was giving the result to be a scalar quantity, then it is considered to be a scalar product. When two vectors are multiplied and the result is a vector quantity, then it is a vector product, and it is defined as a cross product. Okay, and it is written as A cross B. Vector A cross vector B is defined as magnitude of A into magnitude of B into sine theta n cap. Now try to understand this. Okay, say for example, you have this vector A. I am trying to explain it here. Okay, say you have vector A cross B you want, then it is defined as AB sine theta. It's just a what you call it, definition, n cap. Now how to find the direction of resultant vector? Try to understand. Say for example, this is your vector A and this is the vector B. Angle between them is theta. Now AB sin theta is to be found. It is very easy. A is the length of vector A, B is nothing but length of B, that is magnitude of B, and theta is say 30 degree. Then sin 30 you take, then value of this AB sin theta you will get. Okay, AB sin theta you will get. Now what is n cap? N cap is a normal to the plane formed by this vector A and B. If vector A is here, vector B is here, then the perpendicular to this will be this direction or the downward direction. Try to understand. The plane which is formed by vector A and B can be either upward or downward. Now in which direction this A cross B will be? Now just you have to imaginarily rotate vector A in the direction of B. If you rotate this vector A in the direction of B, then this right hand screw you must have seen, all the screws generally are right hand screw, in which direction the screw will go. Okay, if you rotate this screw in the direction from A to B, then it will advance in the upward direction. It will advance in the upward direction, which is normal to the plane formed by vector A and B. So direction of this vector A cross B will be in the upward direction. Now if you find B cross A, then what will happen? If you rotate this in this direction, okay, then this screw will be moving in the downward direction, so the resultant vector will be in the downward direction. That's all. N cap, n is the normal to the plane formed by the vector A and B. So if you are rotating vector A, say for example this is your vector A and this is your vector B, and if you rotate this vector in this direction to find A cross B, okay, say this is B, this is A, then in which direction the screw will go? Just you keep screw whichever way you want to keep. If you want to keep this way, then also it will be moving in the same direction only. Say if you rotate in this direction, if you rotate like this, then what will happen? The screw will move in the upward direction. So that will be the direct. Either you keep downward screw, the head must be up or down, it doesn't make any difference. It will advance in the same direction. Okay, so if you are moving, say for example you have these two vectors A and the other vector is B, and if you keep the screw like this, okay, screw is like this, okay. Now if you rotate this vector A in the direction of B, then this, if you rotate it, then it will move in the upward direction. So if you are finding A cross B, then the direction of the resultant vector will be in the upward direction. That much only you have to understand. If you want to find B cross A, then it will be advancing in the downward direction. So we can say A cross B is not equal to B cross A, or we can say A cross B is equal to minus B cross A, because the direction of resultant vector will be opposite. Okay, this is the first property that you should understand. The other properties are also there. Okay, the other properties are same, which can be understood easily. Okay, if it is A cross B plus C, okay, B plus C, then you can write A cross B plus A cross C. You can open the bracket, but order is very important. Okay, now if you have A cross A, same vector is multiplied with it, then say for example vector A is there, then what is the angle of vector A with itself? With itself the angle will be 0, so it can be written as A sine 0. Sine 0 is 0, so A cross A will be equal to 0. So if vector is multiplied with itself in a vector product, then it will result into 0. Okay, now if you take say I cross I, as we have seen I cross I cap is the unit vector in x direction. Now see, I is having its value to be 1 unit, so we can write 1 into 1 sine 0, because the vector I is having angle 0 with itself, so this I cross I will be 0. Similarly J cross J and K cross K will be equal to 0. Now try to understand the new property. Say for example these are the what you call it, two axes. Okay, this is your x axis, this is y axis, and this is unit vector in x direction, this is unit vector in y direction. Now what is the angle between them? I and j is having angle between them as 90 degree. Now if I cross j is taken, then it is 1 into 1 sine, what is the angle between them? 90. Sine 90 is 1, and normal to it will be the final answer. So if you rotate I in the direction of j, then in which direction the screw will come? The screw will come out of the screen. Screw will come out of the screen. Okay, and that is the direction of z axis. So that I cross j will be in the direction of z axis, so it is written as k cap. So in general, if you find I cross j, j cross k, then it will be I cap. You can just try on your own. So just we have to remember this circle I, j, k. If you find I cross j, then it will be result to k cap. J cross k if you do, then it will be I cap. And if you find k cross I, then it will be j cap. Okay, in the reverse direction if you move, then it will be negative. If you find instead of I cross j, j cross I. If you find j cross I, then this rotation which we have considered this in this direction, instead of that we have to take in this direction, or we can say clockwise direction we should move, and in clockwise direction the screw will go inside. So it will be minus k cap if you find j cross k instead of I cross j. Okay, minus k cap for j cross I. Okay, j cross I will give you minus k cap. Okay, so I cross j gives you k cap. So j cross I will give you minus k cap. So this circle you should remember. Again I am doing it for you. Okay, this circle is very important. I, j, k. I cross j gives you k, j cross k will give you I, and k cross I will give you j, and opposite will be negative. If you find j cross I, then it will be minus k cap. Okay, so these are the properties. Okay, now how to find as such the value of this a cross b. Say for example you are having two vectors, vector a as ax I cap plus ay j cap plus az k cap. Similarly vector b is having bx I cap plus by j cap plus bz k cap. Now if you want to find a cross b, then just we have to put it like this. This is called determinant. Here you write I cap, j cap, k cap. This you will study in your mathematics. You write x component here, that of a, that is ax, ay, az. Here we have to write bx, by and bz. This determinant if you open, then you will get the answer for the resultant vector which we are getting after a cross b. Okay, how to open this? Now that is a trick which is given here. Okay, how to open this? Okay, so if I am writing again the determinant I, j, k, then ax, ay, again I am writing, it is not proper, it is I, j, k, ax, ay, az, bx, by, bz. Now how to open this? First you take this first element, that is I cap, then you close this column you close, and this row you have to close. Then you take the cross product of these two, then you will get ay bz, then you put minus, it will be az into by. This way you take cross product, and this way you take cross product. So first element we got. Now write minus j cap. Sometimes plus also is taken, but in conventionally we generally write minus j cap. Always second term is minus. Then close this column, and then this row we have to, rather this column we have to close. This row we have to close, and this column we have to close. Okay, now you take the cross product of this to this. So what will happen? ax bz, always put minus, az, then it will be bx, then last term plus k cap. Now what will you do? You just have to close this row, and this column is closed. Then this, again I am just changing the color because now it is too much. This is multiplied with this, okay, so it will become ax by always minus, then it is ay bx. Okay, so this way you can open this. If you place plus here, try to understand, if you place plus here, then this will come here and this will come here. Okay, in textbook it may be like this, but you can always put minus here and it can be done in this way. You have to just remember that second term is minus with j cap. Okay, so this can be tried by yourself 2-3 times. Try to open this. These are the different properties of vector product and all. Okay, now we shall move further with topic number 7.6, that is angular velocity, in the next lecture. Okay, thank you very much.